Hello, algebra students. Welcome to Chapter 5, Section 6, Parallel and Perpendicular Lines. As it's going to get a little bit crazy as we throw a new thing into all of these equations and continue to have to apply all the things that we've learned in the past 3 equations we've been working on. So it's Chapter 5, Section 6 in your book. Please hit pause as you need to, as I'm going to start rolling through this material here. Number 1 says some review information. Circle the product of a number and its reciprocal is equal to 1. If you multiply two numbers together and the product is 1, that is a reciprocal. The two numbers are reciprocals of each other. So number 2 there says circle the pairs of numbers that are reciprocals. Well, these two are reciprocals. And again, looking back here, if you multiplied 7, which is over 1, right? 7 over 1 times 1 over 7, that would be, it's an equal sign, 7 over 7, which is 1. So those are reciprocals. These two are not reciprocals because if you multiply 1 times negative 1, that would equal negative 1, so those are not. 0, you can't multiply 0 times something and get 1. So those are not reciprocal. Take a look at this one, negative 3/4 and negative 4/3. Those are reciprocals because that would make, negative times negative would make positive. You'd have 12 over 12, which that does equal 1. Therefore, those two are reciprocals. Okay, and all of those, the reciprocal is going to be an issue here for us in this particular lesson. Scrolling on down to the bottom here, parallel versus perpendicular. It asks you to just review what these are. The railroad tracks in picture A. Okay, those two railroad tracks are parallel. Just to make sure that you know what we're talking about as we get into parallel perpendicular lines. The window bars in B that do not meet, that's talking about like the lines straight up and down. That with that one, for example, those are also parallel. And then the third one, the roads in picture C, that is perpendicular because they meet at a 90-degree angle. Okay, so that's perpendicular. Two lines that meet and they form a 90-degree angle in the corner. Kind of like the corner of a door would be perpendicular. So that's what we're looking at in this particular lesson and how we can relate this to the coordinate plane and the equations we've been working on here. So the key concept, okay, take note here. This is important and gets really wild if you don't keep up. And it's really tough if you do keep up. So pay attention here, right here. Non-vertical lines are parallel if they have the same slope. Now, if you really think about what's happening in the grid, it really makes sense that parallel lines have the same slope. Okay, and there's a little bit more into this, which is true. They have different y-intercepts. Like here's an example of two parallel lines. They go through different y-intercepts, but you'll notice the slope on both of these lines is 2 over 1. Take a look at this one, 2 over 1. So they're parallel. So it makes sense that if two lines are parallel, they would have the same slope. Now the rest of this information is true. Their slopes would be the different intercepts. Now it does say this, vertical lines are parallel if they have different x-intercepts. And that just means if vertical lines don't have a y-intercept. That's why they threw that sentence in there for you. Okay. Number 6 says draw a line from each equation in column A to an equation whose graph is parallel in column B. All right, so if I look at this first one right here, according to y-intercept form, that 2 is the slope. So I'm looking over here for an equation that has 2 for its slope, and right there is 2. So I know that these two are parallel. So that's what we're doing here. We're looking for parallel lines based on the equation. So notice we don't even have to graph these to answer the question yet. This one right here, if I have 1/3, now notice it is in slope-intercept form, y equals mx plus b. So 1/3 is parallel to 1/3. Now this last one here, x equals 3, well, that makes a lot more sense if we're visual about it. If you don't know what that means, you really should know what that means by now. But that means that there is a line that goes through x equals 3, a vertical line like this. That would be an example of x equals 3. So a line parallel to that would be like this one where x is 2, it also goes straight up and down. So vertical lines are parallel. There, that's x equals 2. So these two lines are parallel because they both basically have the same slope, it's just no slope or undefined slope. So here's where it gets a little bit crazy. Take a look at 7, 8, 9 as we roll through this. It's like you're going to have to become a detective. And I've said that before in class, and it means I'm going to give you hints, or the questions will give you clues. Based on what you know, you should be able to solve them, like number 1. Okay, if we know the parallel lines are the same slope, we can solve this question that says, a line passes through this point. All right, so I know that -3, -1 is on my line. This line I'm looking for. I'm looking for an equation to my line. And I know that that is parallel to this line here. Now, this is not my line. This is parallel to my line here, okay? Then the question says, what equation represents the line in slope-intercept form? So there's a lot happening here. The first is that they have said that you have to put your final answer in slope-intercept form, but they haven't given you the slope and they have not given you the y-intercept yet, but we can figure those out. Now, this is going to talk you through the question. Number 7 says the slope of this graph, they're talking about this one here. Remember, this one is not my graph. Mine is parallel to this. Well, the slope of that line of 2x plus 3 is 2, right? Because there's m. It's solved for y. Y is isolated, so I know that the coefficient of x is 2. All right, so the slope of my line is now 2. The slope of any line parallel to this graph is 2. They have to have the same slope. Okay, so I know now that this point is on my line. And now I know that my line has slope 2. Now think about it. If I know my line is slope 2, and I know that this point is on my line, do we have an equation that we can use to create an equation? Yes. This point-slope form. You can use point-slope form to create an equation if you know a point that is not the y-intercept and the slope. So I'm going to use point-slope form to create an equation. All right, let's do that. Y minus, now I know I have the point, -3, -1. Okay, so there's x, y. So y minus -1 is equal to the slope is 2. Remember, we figured that out here. Times x minus the x value is -3. Now let's go through and let's change this to addition. Minus negative is plus positive, minus negative is plus positive. So what I want to do now is put this into slope-intercept form, because here's what you've just found. This is an equation of your line, or I'll say my line. However, the question said, write your final answer in slope-intercept form. So you have to continue. If this question had said, hey, just write me an equation of a line parallel, this would be an acceptable answer. But it asks you to go ahead and put it in slope-intercept form. So we need to do that. We need to solve for y. Right, solve for y. We have to isolate y. So we need to distribute the 3. Before we do anything, we have to get rid of parentheses. So I have y plus 1 equals 2x plus 6. I distribute 2 times x is 2. 2 times 3 is 6. Now, we need to subtract 1 minus 1 minus 1. It's the 6 and the 1 that can be subtracted. So that cancels out as 0. You're left with y on this side. And you're left with 2x plus 5. And there you have it. You have slope-intercept form, and you have a line that's parallel, excuse me, it's parallel to this line right here. And this would also go through the point 3, -1, because that's where we got it from. We started with that. So that's parallel lines. So That takes care of this video, but I'm going to come right back and then talk to you about perpendicular lines because we have an equation for that. If you have two lines that are perpendicular, we can write an equation for that as well, and that's coming up here in a moment. So continue with the next video as soon as you're done with this one. Thanks.